Hello and welcome to another Clojure Diary video. So I had a Clojure interview and I was just given this question, but I didn't solve. Like, unfortunately, I couldn't make it. But I would have really loved if I made through that interview and got a Clojure job. But yeah, this was the question, and yeah, like finally I've just to say solved it. So, but of course, the person who asked the question told me how to solve it. Yeah. So yeah. So you have okay, this is called as build order. So you have a graph of build steps. Let's say h depends on nothing, right? That is, the build step h depends on nothing. The build step c depends on builds a and b, and the build step e depends on builds b and f, and build step g depends on builds c and e. Okay. Another thing I just want to add is, like, if there is some Clojure puzzle books or something like that, if you people can comment it, maybe I will go through it and put solutions for that. Okay. So that's the thing. Okay. So you just have this graph and you need to find the build order. So how you find the build order? You just, what to say, write a function called build order and pass this graph and you get it. So how this works? Okay. So let me just put a new file over here. Right. So I'll just put a new file and I'll just put it over here. Right. And yeah, this is a graph. Okay. So first it checks, okay, which thing has no dependency? H has no dependency, right? So that's the thing. And what it does is, so like it kind of removes H out of the graph. Okay. So, and it also checks which has no dependency. A has no dependency. So it removes all instances of A, right? So yeah, there's only one thing. And it also finds that B has no dependency and it removes all instances of B, right? So yeah, now what happens? Like, and even, yeah, finally, I think C has no dependency because this is empty stuff. So it removes C too, right? And then similarly, now I think, yeah, C also gets removed from here, right? D has no dependency, and similarly F has no dependency. Okay, like, okay, yeah, D has no dependency and F has no dependency, right? Okay. So if you look at the right, this is the same order we are just getting. Now, okay, E has no dependency, right? So E gets removed. And G has no dependency. Okay, yeah, yeah, E gets removed from here. Now G has no dependency and G also gets removed from here. So it goes on till, like, okay, it finds no build step. Okay, so that's the thing, right? So this is how it works. Okay, so this is how you build it. So yeah, for this there is Clojure code. Okay, so right. So what I'm just doing is, like, okay, I'm just creating a function called has no dependency, right? So what happens is, like, okay, I'll just has no dependency. I don't know why this isn't auto completing over here. Okay, yeah, let me just copy and put it. Okay, so okay, so I'll just put like this. Okay, has no dependency, and let me just put something like, okay, like G and graph. Okay, so, and if I execute it, it says false because G has dependency, right? So that's the thing. But let's say, what about A or H? Okay, so, like, if I just put like A, okay, A has no dependency. That's true because, yeah, A is just over here. It's just as a leaf, like, it's not pointing to anything, right? So, and but C has dependency, right? C has dependency, right? So that's how it works. And just a second. Okay, yeah, fine. So, okay, yeah, this is how it works. Okay, so yeah, so what I just do over here is, like, I just have this node over here, right? And in this graph, I just get a node. And if there is nothing, let's for A it will be nil, right? So if I just take, like, okay, like, get graph and then A, and it'll be nil, right? So it'll be nil, right? So, and so what I'm just doing is, instead of that, I'm just passing an empty list or a vector over here, right? And if it's empty, I'm just saying like, okay, like it has no dependencies, right? So, that's the thing. Yeah, it's just to deal with this nil condition, right? So that's the thing, right? And okay, so now there is another thing called build all steps. Okay, so what I'm just doing is this. Okay, sorry, all build steps, all uh, build steps, build steps. Okay, so what it does is it just gives all the build steps. It doesn't care whether it, what to say, like it has dependency or not. Okay, so how it does is it takes all the keys and it takes all the vals. Okay, so right, so keys is very easy. Like you just take, okay, like keys and graph. Okay, so that's the thing. Yeah, and vals is also quite easy. Vals and then graph, and you get this. So you need to concat this. Okay, so like, okay, like you just can't put concat like this. Okay, so and what happens is if you just do like that, okay, concat takes multiple sequence as arguments. Okay, so what you need to do is like you need to remove the, I mean, concat doesn't work like this. Okay, so yeah, okay, it just gives like this, but in order to remove the outermost layer, this outermost list, you just put apply, right? So that's how it works. Okay, so now you just get vals. Okay, so and now what I'm just doing is for final thing is like I'm just concating uh, keys and vals. Okay, so that's the thing, right? So that's what I'm just doing. So I'll just get all builds and I'm just returning all builds over here. Right? So that's how it is. And okay, right. Okay, so now yeah, let's go to this build order and see what it does. Okay, so like, and then yeah, I'll just from top down, I'll just explain one by one, right? Okay, so um, okay, right. So yeah, so there is this function build order and graph and then build steps. Okay, so that's the thing, right? So and okay, so initially what I'm just doing is in build order, I'm just calling this build order again with graph and build steps will be nothing. So the moment we find a build step that has no dependency, it will be added to this. So this vector over here, right? So that's how it works. Okay. So what I'm just doing is like I'm just telling the code to recommend a build step. Okay. So um, for this, what we are just doing is okay, like we are taking all build steps in variable called all steps. Okay, and what we are just doing is we are taking okay, like everything that has no dependency, everything that has no dependency. Okay, so like I'll just okay, yeah, so we are just taking everything that has no dependency and I'm just recommending the first. Okay, so right, okay, so like let me just execute this. Okay, so like, okay, like def all steps is nothing but like all build steps. Okay, so I'm just taking this, right? Okay, so all steps will be this one, right? So it'll be this one, right? Everything, right? So now I'm just filtering, okay, like that stuff that has no dependency, right? So I don't know where this filter ends. Yeah, I think it ends over here, right? Okay, so am I doing it right? Okay, hopefully, yeah, this is right. Okay, so okay. So like, oh yeah, yeah, it just filters the things that has no dependency, but it just takes the first one, okay, because I just want to build it one by one. Maybe this is a bit more inefficient, but yeah, like that's okay for me, right? So yeah, okay, so So now what I'm just doing is, okay, if there are no build steps, return this one build steps. Otherwise, what you do is you remove the keys and values. Okay, like okay, like let's say like there is this graph. Okay, there is this graph. Okay, so let me say I just want to remove keys and values. That is C. Okay, remove keys and values, and then I just want to remove C. Right. Look, C is over here. It's here as a key. So this should be removed and value, it should also be removed. Okay, so right, okay. Like, oh yeah, okay, fine. I just got it over here. So C has been totally removed. Okay. So how that works? Okay, so right, okay. So remove key is nothing. You just disassociate a key from the graph. Okay, so I'm just in fact renaming it, doing nothing special over here, right? And yeah, that's how it is. And remove value, okay, what it does is, okay, like okay, so it uses this method called update. Okay, so if you want to see update, it's over here. So the code is over here. And so what it does is, right, so of course, like I took it from Clojure docs. I just wanted to see what it means. Like they had given something like, okay, like they have given it in a cryptic way, okay, like MKF and XYZ and more. I didn't understand, so I just wanted to read what it's over here, right? Okay, so what does it mean is, okay, like uh, okay, so this is nothing but a map. Okay, so this is key of the map where its value should be updated, and this is the function that will return something that needs to be updated, and these are all the arguments of the function. So I didn't understand what is this XYZ and more. Okay, so I just want to tell one thing, like I just want to say the difference between Ruby and Clojure. In Ruby, like one will name it like, okay, input map, and the key that needs to be updated, yeah, we would name such a long variables. Okay, and function that will update and function arguments, that's how we will name it. Okay, so like so that like it's more readable. In Clojure community, what I just find is they're giving this all this one letter name, but they're just putting a what to say, like a documentation over here. Maybe it's got to do with history of how languages evolved and all those stuff. Okay, so that's the thing. So okay, so what we are doing is like, okay, like okay, so okay, like we have this remove value. Okay, so we have this graph. Okay, so we just have this graph. So okay, right. Let's say I just want to remove this A from the C. Okay, so what I'll just do is, okay, I'll just give remove value, right? And I just have C, and let me just give it as A, right? Okay, so this is the thing. And what happens is in C, this A gets removed. Okay, so that's the thing. Okay, so that's how it works. Okay, so that's the thing, right? Yeah, and for this, I'm using this function called remove element. Okay, so like what I'm just doing is I'm using this method remove, right? So if okay, this C has this A and B, right? Okay, so if the element is equal to A, right? So that element gets removed. So that's how this works, and this is being called in removal. So that's the thing, right? And okay, right, okay. So okay, so that's the thing. And now you want to remove multiple values, right? If there are multiple values, if there's a at many places or something like that. Okay, so that's the thing. So what I'm doing over here is like I'm just using this um, I'm just taking graph and value for this. Okay, so I'm taking all keys in this graph. Okay, so for each and every key that is over here, for each and every key, right? So like I am passing this graph, okay, and I'm removing this value. So let's say even if A is over here, like okay, so graph is like this. Okay, so right? So this is the graph. Let me just put something like graph 2, right? So just put something like graph 2, right? And let me just put another A over here, right? Another A over here, right? And I'll just put like, okay, like remove values, ALUES. Okay, so graph 2 and A, I'm just putting. So you see A from every, what to say, vector has been removed. Okay, so that's the thing. So A is being removed from here and A is being removed from here. So that's what this thing does, remove values. Okay, so okay, having explained this thing, now this build order becomes very easy. So all you just need to do is, okay, like, okay, if there are build steps, okay, so that's what it comes over here, right? It just, okay, and I just have this function remove key and value. So what it does is first it removes the key, right? And then it removes the value. Let's say like I just have another thing like graph 3, right? So graph 3, right? So and I just have a thing called I just have a thing called A, and that depends on, okay, like B and E. Okay, something like that. Okay, so like okay, so I don't know whether this is a valid graph or something like that. So now I just put graph 3 and remove A. It removes the values, it removes this key A also. So D and E also gets eliminated, right? And it also removes all the values A over here. A will be removed from here, A will be removed from here. So it accomplishes this using very simple stuff. So first it removes this key. So the A will go, and then for each and every element, like it just removes this value. Okay, so that is, yeah, it uses remove values for that. So that's how it happens. Okay, so now, okay, if there are build steps, what I'm just doing is I'm just removing key and value. Okay, so and for the recommended build step, okay, so the first recommended build step will be H, I think. Okay, so that's the thing. And then the second recommended build step will be A or something like that. So, and what I'm just doing is I'm reducing the graph. So I think first H will get removed. So as I explained before, right? Maybe I explained over here. So this is how, this is the order it would get removed. Okay, so oops. Okay, so first H will get removed, right? And then it'll find that, okay, A has no build steps, so A will get removed. So that's what happens over here. So like each and every time I'm passing the reduced graph over here, and the recommended build step will get added to build steps over here. Right? So that is yeah, so that is recommended build step. We are calling it as build step over here. So that will be added to build steps over here. And finally, if there are no recommended build steps, this gets returned. So this is how build order works. Okay, so I wish I had found the solution and maybe like I got the job, but yeah, like no, like maybe I'm not good enough for Clojure. But yeah, if you have got uh any job for a newbie Clojure guy or something like that, yeah, I would be very interested to hear from you. So anyway, thanks for watching. Until we meet in next Clojure Diary video. Bye.